Welcome back to Database Fundamentals. This is the beginning of Module 3 of the Database Fundamentals course. Module 3 is going to be a fun one. We're actually going to talk here in this module about creating databases and database objects. So
we get to create something finally.
We finally actually get to do something real instead of all this theoretical stuff that we've been doing. But let's just review. In Module 1, we talked about sort of core concepts of databases, some terminology, things that we've covered. Then in Module 2, we talked about, what did we talk about? We talked about referential integrity and normalization and sort of a little bit of modeling, but not quite modeling. We didn't get into some of the details of modeling, but we talked about referential integrity, normalization, a little bit about constraints. And now here, finally in Module 3, we're actually going to create our first database. We've only looked at diagrams so far, except for your quick demo of SQL Server Management Studio. We're going to create databases. We're going to create database objects. You're going to tell us what kind of objects we're going to create, things like that. And then in 4 and 5, we're going to head on, coming up, we're going to talk about how we actually use those objects with this T-SQL language in Module 4 and then administration in Module 5. So
some real work. Some real stuff now.
Let's create. I can't wait to see how this is going to go.
So yeah, creating databases and database objects. First thing we're going to talk about data types, because before we can create objects, specifically a table, we need to understand what types of data we're going to store in there. And that's really huge about, it's huge to understand. So we've kind of talked about creating different columns. We've talked about creating the artist ID and the album ID. Well, we need to identify what type of data is going to be stored in each of these columns. So it's not as easy as it is in Excel where you just throw a column out there and just say, yep, just throw whatever you want in that data in that column. We actually have to think about, this helps with the data integrity, we have to think about the type of data we're going to store there. We're going to store numbers in there. We're going to store money. Is it going to be a date field? Is it going to be a character field? And we have all sorts of options. So we're going to introduce data types first. You have to have an idea as to the type of data that you're going to store. That's something you need to do and think about in that data modeling phase that Pete had brought up earlier. So we'll look at data types. So we'll look at database objects. We're just going to mention just a few of them, the most commonly used objects. And then we'll look at DDL, data definition statements. So statements are used for defining new objects. So we'll introduce the statements that are available associated with DDL statements, and then we'll use a couple of those statements just to show you how they all work together with us. So data types is going to be our first category that we're going to talk about. And in here we're going to begin with an understanding what that is. So we've talked about rows and we've talked about columns. Well, the columns are what we use to identify that we assign a data type to, which identifies the type of data that's going to be allowed or stored in that particular column. You have similar data types. There might be a couple different data types that are similar. The idea is use the data type that has a larger range of values just to make sure that you have a better chance of increased precision, and you make sure that you don't have an overflow error by not having a data type large enough to be able to store the content. Some exact numeric data types are int and tiny int, and these are probably the most commonly used data types because they're storing numeric information. And then we have approximate numeric types. These include precision, so it's indicated by a letter P, and that gives us the total number of digits, decimal digits, that can be stored both to the left and to the right of the decimal point. So all of this has to be considered when you're trying to decide what columns am I going to create for my new table, for instance, and what type of data am I storing in there. When we talked about the album ID, is normally going to be, most likely going to be a numeric type value. Description or title or artist, that might be more of a character field. So these are things that we need to think about. The other thing we need to think about is how are we going to use these forms, these columns or data types. For instance, if I go out and I create a data type of a character field and I put a number in there, I'm not going to be able to use that in a calculation. I can't multiply in a character field. It has to be a numeric field for that operation to take place. So there's some things that we need to be aware of when we're working with our data types. We have what are called Unicode data types. You'll see that often. These provide storage for international characters. So non-Unicode data types are pretty much specific to the USA and the New England, or not New England, English data types or characters. But if you want to bring in other languages, native languages, we have to use the Unicode data types. Unicode data types take more storage in the database itself, but you have to be careful about that. But those two things are a couple concerns that we have to think about when we're looking at data types. Now, there are several categories that are provided with us with SQL Server 2012. And I mentioned already we have exact numerics. We have big int, and we have bit, we have decimal, int, money, approximate, float and reals, date and time, I mentioned that one, character fields, Unicode character strings. Then you get the letter N before, that means it's Unicode. That provides support for the international languages. Binary strings, and we have some unique data types, other data types like a timestamp or a unique identifier. Some of these are actually taken care of or managed by SQL Server. So it actually, timestamp, for instance, it stamps, takes a system time, it stamps that or applies that to the record as you're applying that. And we have a couple other ones, large value data types and large object data types, which we will see for storing images or specifying the maximum amount that we want to allow in a particular field. So data types we have to understand how we're going to use them, and understand they're going to enforce data integrity for us by, for instance, if I have an int or a tiny int, I'm not going to be able to put the letter A in there because it's not the character field. So it enforces data integrity with the use of, by enforcing the information that's being supplied. It also controls what we can do with that content or those values once they've been added. So we have to make sure when we're going through this that we think through that as we're creating our data types here. So here's a couple common ones. We've got money. So if you're going to store currency, you can control these. Most of these have options where you can decide how many decimal points that you want to the right or the left of them. We have int, used to store whole numbers. We have a float, sorry.
Is int short for something?
Short int, yes. Int is short for integer. Thank you very, very kindly.
Ah. Yes.
I see, I just assumed
You blew right past that
I
one.
blew right past. I
That's
did
right.
it a couple times. So the tiny int is tiny integer, or the int here that we see here is integer. Big int is big integer. So some of those short names, I'll try to be more aware of that. Thank you for catching me on that.
But I also want to back up before you finish this slide. You've gone to a list of the sort of kinds of data types, numeric and non-numeric, and then you've gone into some specific data types that are actual keywords in SQL Server. So two things I wanted to say. Number one, it's specific to the database system that you're using. So right, you're talking about SQL Server, which is important because that's what our demo is going to be. But there's a different, shorter list of data type choices in Access and in other database systems,
That's
right?
correct,
And they're very similar, but that's one of the ways that the choice of what database you use, what database engine you're going to use,
right,
that's one of the deciding factors. Is if you need unique identifier or some of the really advanced data types, you might need to use SQL Server because it may not be available in Access or a smaller database engine.
Yeah, both, like you said, most of the relational database products associate with the ISO, the standard for databases. So if you learn one database, you don't have to jump over and learn a brand new data types. But Microsoft SQL Server, as other products, have some unique variations of what is available or supported, we'll say, via ISO. So,
Great.
ISO, what does that stand for again? International Standards of Organizations.
International Standards.
Yeah, one of those
trivia
things.
question.
Yeah,
that's right.
It's a trivia question. There we go. So that's all right. So we have int, short for integer. We have float. That's often used if you need more precision. We've got more in the scientific community, and then often we're looking for dates or times and stamps. So we have a date time field as well. So those are a few of the variation of those types of data. Getting the more of a couple other ones are char, short for character. And anything can go in a character field, so we can put numbers and alphabet in there. So it's a alphanumeric characters can be stored there. Variable character, so a char, which is short for character, has a fixed length. So if I do a char 20, it's going to allocate 20 spots for 20 bytes, I believe. Bytes or bits? I can't remember that.
I don't remember.
20 somethings. Chars. So it's going to allocate that number. Now, if I only use 4, there's going to be 16 unused. So it's a fixed length. A varchar, variable character length, if I put 20 in there and I store 4 bits of information, then the other 16 bits, it's only going to allocate what is needed to store the content that's in that type of field. So that's the difference between those two. Another data type is a bit. Sometimes you'll see it as a Boolean. This is often just going to return a 0, which is false, or a 1, which is true. So it may be as simple as, if I want to go out and check, does the date field equal today's date? And it returns yes, or a 1. If it does, then we can have some programmable code or programmatic code that allows us to go out and perform some other task. we can do some calculations. We can do calculations within the fields themselves, just using the data, the data types that we're creating. We can also use something like the date time offset, where we can actually determine the difference between a couple dates or the offset of those dates. So some of that functions available to us. Here's an example of some of the different data types in the storage. For instance, as you can see, the int, short for integer, can store a number from minus 2,147,483,648 to plus, it should be plus 2,147,483,647. So it's 2 to the 31st if you look at it that way. Char, for instance, fixed length, non-Unicode data, any value from 1 to 8,000 characters. The bit we talked about already, and the date time offset we talked about already. So these are, again, things that we have to consider when we're creating our new tables, when we're trying to create our relationships between those tables. What are we going to use the data for? We could just easily create everything in char or varchar to save space, but when we do that, now we have issues if we need a date, a timestamp, or if we want to try to perform a calculation. We'll have some restrictions with that. So we have to think through this when we're going through the data modeling and designing our tables for our database. So these are some examples of the size of the information and what's stored here. Now we may have a situation where we created a data type on a field and we want to perform a calculation on it. Well, we can do what a SQL Server will do is what's called an implicit conversion. So there's implicit conversions and there's explicit conversions where I need to do the conversion myself. I need to use either cast or convert. Either of those commands allows me to take any of these data types and convert it, I won't say any, most data types, and convert it to a different data type. So if I want to be able to perform a calculation, as long as the number was in a character field and I want to convert it to an int so I can perform a calculation, we can do some data type conversions as part of our program, and we're doing some programs and using some of the different objects inside a SQL Server. But the best thing to do, if you can, is to create the data types with create the columns with the appropriate data types, taking into consideration the type of content or data that's going to be stored in there and any type of calculations you may be performing with that data once it's actually stored in there. And there's an example here in the slide of casting, $157.27 as a varchar. So it's going to convert that and now store that as a varchar and be able to work with that using that new data type here. But again, not everything's supported. For instance, an nchar cannot be converted to an image data type. Most everything, as you stay within the common data types, you're pretty safe. But if you're going to get into some more unique ones like image, those you have to be a little more cautious about. So we talked about we introduced the ISO. The cast and the convert can both be used for doing explicit conversion. The cast, as you can see, it's recommended you use that because it does adhere to ISO. Now, Microsoft or other products have decided to create another flavor of that called convert, and they can do so and still take advantage of that and still use it. Just gives it a little bit of a different variation.